Hey, everybody, welcome back to The Doctor's In, the Controlled Environment Agriculture podcast, where we focus on optimizing the indoor plant environment for crops growing in greenhouses, indoor farms, vertical farms, plant factories, containers, and any other facility where we want to grow plants anytime and anywhere. I'm your host, Dr. Nadia Sabeh. So I just got back from the NGMA annual meeting. That's the National Greenhouse Manufacturers Association, where I gave a presentation about California's new energy code. They gave me a lot of time to speak, so I kind of workshopped my presentation and engaged the audience, asking questions about what they thought were some low-hanging fruit and opportunities for saving energy in a greenhouse. It was a really great discussion. A lot of people had really good ideas. And so I just felt like I wanted to share those with you for today's podcast. So when it comes to energy efficiency opportunities, I asked everyone, please raise your hand. What's like one of the first things that comes to mind? And right off the bat, several people suggested that using thermal energy screens and shade screens could save a lot of energy, especially when thinking about the new energy code requirements in California around double glazing to improve the U value or insulation value of a greenhouse. No longer are we allowed to use corrugated polycarbonate or single film polyethylene or acrylic. We now have to use a double glazing that's insulated or inflated with air or argon or some other insulating glass. This is going to have a major impact on the industry. It's going to increase costs, it's going to increase materials uses, and honestly, for a fairly low return on energy savings, especially in temperate climates like we have in California. On the other hand, we could save a lot more energy if we could use thermal energy screens and shade screens either to trap the heat in, say at night or during cold weather with a thermal energy screen, or to block solar radiation from coming in using shade screens. They all come in various percentages of energy savings and reflectivities, and by all accounts are really more effective than the envelope when it comes to energy savings for a greenhouse, because a greenhouse, right, we want a transparent envelope. We're trying to bring light in during the day to hit our DLIs and create photosynthesis by the plants. And so, by adding that double layer, we actually reduce the light transmissivity, which can be, a bad thing for growing crops and for yields. And we don't really get a lot of energy savings in terms of convection and conduction, like, we do with a building and having really high R values, really high insulation values, and I do think that this is a great opportunity. We recommend on almost every single greenhouse some level of shading to reduce the cooling requirements. If we're in a cold weather location, then we always recommend having some sort of thermal energy screen. Sometimes you can get one screen that provides double duty. It provides both of those energy saving opportunities with one type of shade screen. The challenge is, at least in terms of the California Energy Code, is that the utilization of these energy and shade screens relies on the operator to use them, right? I mean, when it comes to glazing, that is designed and built into the infrastructure of the greenhouse. That is very easy to regulate. That's very easy to standardize. But when it comes to screens that, rely on the grower to open and close them or to apply them to the greenhouse, either as a coating or as a fixed infrastructure inside or above the greenhouse, that the Energy Commission doesn't really want to have to rely on users to utilize energy efficiency options. They want it built in to the building. So that's the really big challenge, at least when it comes to the energy code. But in terms of energy savings, it can be great, both again in terms of cooling in the summer with shade screens or heating in the winter with thermal energy screens. So even if it's not required by code, and that is okay, it is still a great industry best practice when you are designing and operating your greenhouse to save energy. Okay, the second thing that everybody brought up, or several people brought up during the NGMA meeting, was variable speed fans. Again, I am a huge proponent for variable speed anything. Having the ability to modulate the various components that you use to manage the environment is not only going to improve energy efficiency if you don't have to operate them at their highest power, but it also improves the stability of your environment, right? If you have equipment that kind of slowly ramp up or ramp down, depending on what's going on outside or depending on what you're trying to hit inside and what your plants are doing, you can really improve, the stability and uniformity of your climate without having, big equipment, big fans or big compressors, if we're talking about an indoor farm, turning on and then turning off. And those of you who have dealt with those type of systems, right, you see spikes and dips in the environment, and you know exactly when that fan turned on, you know exactly when that compressor turned off, right? Because you can see it in the environmental data. But if you have variable speed components, then we can really flatten those peaks and valleys when it comes to managing the environment. So with variable speed fans in a greenhouse, we typically think of greenhouses having these big exhaust fans, right? And they turn on and at 20,000 CFM, and they might be staged. Maybe you have two stage fans, and the first stage comes on at 10,000 CFM and the second stage comes on at 20,000 CFM, but they're still just turning on and turning off. With variability, they're going to slowly ramp up and down. And there are two common types of fans that we would use to get this variable speed or modulating control. And those are VFDs, or variable frequency drives, on an AC motor, as well as electrical commutated motors, or EC motors, on direct drive fans. Again, it saves energy because we're not always operating at its max power demand. We have that more stable environment that I was describing, but also reduces wear and tear on the motor, right? And it improves the longevity and lifespan of that motor because we're not just kicking it on and kicking it off. It also saves potentially on power surges. So, a lot of you are operating, or have energy utility bills that the cost of energy is determined a lot of times by the peak power demand that your facility used in a month period or in an annual period. And that determines what your energy rate is going to be in the following year, following quarter. And so if we have fans that can kind of slowly ramp up and down, we aren't going to have these big power surges and big amperage draws that are going to cause you to have big power bills, right? Or a higher energy utility rate. There are challenges, of course. Variable frequency drives as well as EC motors do have a higher first cost. They are more expensive to purchase, and I know that can be a deterrent for many growers. They also were talking about at the NGMA that these fans or these types of motors have long lead times, longer than normal. They are in short supply. And when they mentioned this during the meeting, I wasn't really surprised because we are seeing the same exact thing happen with commercial HVAC equipment for our indoor farming clients, right? Where the lead times for HVAC equipment is getting longer and longer as we have shortages of electronic chips that run both the VFDs and the EC motors. We're seeing, some manufacturers who had EC motors switching to VFDs because they became more available, and now VFDs are in short supply. So this is prolific regardless of what industry you're in or what type of equipment you are installing or using. And hopefully, right, we're going to weather this storm and those lead times are going to come down. They're going to become more prolific and the first cost will come down as well, right? The more people who install and purchase these variable speed fans and variable speed motors and drives on any equipment is going to help bring the cost of those equipment down, just like we're seeing with LED lighting. Okay, so the third thing that several members of the NGMA mentioned was preventative maintenance of the equipment. That this is so often overlooked in a greenhouse with equipment. We see the same thing with indoor farms. And so some of the examples that were mentioned during our conversations was, grease the rack and pinions of your roof vents. Some members have gone to site visits, have visited greenhouses where the ridge vents are stuck open because the rack and pinions haven't been greased, and so they're just kind of locked in place, and they're leaking, hot air out in the winter at night and requiring more heating energy to make up for that loss of heat, or vice versa. They're locked closed during the summer when, you could really benefit from venting out some of that heat from, up in the attic of the greenhouse. So just simply greasing the rack and pinions of your roof vents. I would say the same thing is true for any of your openable vents that open for, your exhaust fans. You have louvers, as well as for your evaporative cooling pad, right? If you have a shutter, you also want to make sure that you grease the rack and pinions that are opening and closing that shutter to make sure that it's opening and closing as you need it to, depending on the season. Also, tightening and replacing fan belts. If you have a belt driven motor, check those out. Clean the evaporative cooling pads and the fog nozzles to make sure that, water is freely flowing through them, and isn't, at least for evaporative cooling pads, isn't, preventing air from moving through it because you have that calcium deposit that gets left behind as water evaporates. And especially if you are in a location that has a lot of hard water, you might see that calcium build up more quickly than if you're somewhere that has softer water. And that calcium buildup restricts airflow. It's kind of like a filter, it gets loaded and the fans have to work harder to push or pull air through them. So clean those at least at the beginning of every summer season, if not again, in the fall season, especially if you're somewhere, in the sun belt, you might need evaporative cooling all year round. Also, just remove dirt and debris from insect screens. Also, just like an evaporative cooling pad or an air filter, it restricts airflow by having them really dusty. So clean those off when you can. Check filters on pumps, right? I mean, a lot of times those tanks, they get built up with algae or dust from windstorms, and the filters can get clogged. And the pumps have to work harder, just like a fan has to work harder against, a calcium enriched evaporative cooling pad. The pumps have to work harder against an algae enriched filter on that pump. So same idea, check those filters, clean them often. And the benefits of this preventative maintenance, is it increases, of course, the lifespan of the equipment because it doesn't have to work as hard. You're not burning that motor to push through, that algae infested pump filter or calcium infested evaporative cooling pad. So it increases their lifespan. It also maintains more efficient operation because they don't have to work as hard, right? For the energy we're putting in, they're giving us more energy on the output. So lots of benefits for preventative maintenance of equipment. I'm hearing the same conversations on the indoor side of CEA with HVAC maintenance as well. So just check your equipment often, have a 3-month schedule or a regular preventative maintenance schedule. If you need to hire a service contractor to help you out, it's definitely worth the cost just in energy savings and equipment replacement savings. The fourth thing that NGMA members talked about, either directly or indirectly through these conversations, was education, right? Education of the growers, education of regulators, even education of themselves, right? To understand what do various systems do? how do they interact with each other, right? How does the exhaust fan interact with the evaporative cooling pad? How does your cooling system interact with your irrigation system? How does your shade system interact with your supplemental lighting system, right? When should you be turning things on and off? What systems work together? What systems maybe you want to work independently? So asking questions of your greenhouse supplier, of the equipment vendors, and of the control system supplier and vendor. How are these equipment supposed to work? Why are you choosing unit heaters as opposed to, boilers and underbench heat distribution? Why are we using an evaporative cooling pad rather than high pressure fog system? Why did you pick just a shade screen and not a thermal screen for my greenhouse? Asking those types of questions will help you as the operator understand better how to use those systems, why you're being proposed those systems, and ultimately how to operate them and maintain them in the long run. And you know that is one of the services that we provide at Dr. Greenhouse. Obviously, we really pride ourselves on being educators and trainers of the industry at all levels. And if you ever have any questions about the quotes you're receiving or about the equipment that's being proposed, you can always reach out to us to help answer those questions. But don't be afraid to ask your greenhouse supplier and those equipment vendors, why? What is this for? Why are you, selecting this type of equipment? And if you ever need, a hand to hold or someone by your side just to, I don't know, beef up your confidence or just ask the questions that you don't know how to ask, you can always ask us to support you in those efforts. So, in summary, the four big energy efficiency opportunities that members of the National Greenhouse Manufacturers Association spoke to was one, using thermal energy screens and shade screens. Number two, installing variable speed fans. Number three, enacting preventative maintenance scheduling of equipment. And becoming more educated, asking more questions, understanding, trying to ask questions to understand better what systems you have, why you have them, and how to operate them most efficiently. Okay, well, that was my episode for this week. It's great to hear from you. Please do contact us anytime if you have any questions or comments about this podcast. You can learn more at our website, drgreenhouse.com. And thanks for listening, everybody. Have a great day and keep on growing.